Section 4.4, expressions involving roots. Very often in the exam questions they could ask you to, without solving and finding the values of each individual root, to evaluate the following expressions. So it's really just being able to combine the two reciprocals together into one fraction. So here you will have one with alpha beta in the denominator, and you will have beta plus alpha on the top, so alpha plus beta. Over here you will have the product of three roots in the denominators being the common denominator. Alpha needs to be multiplied by beta gamma, beta by alpha gamma, and then alpha beta on the top. There you go. And this is just the sum of pairs. This is the sum of roots. This is the product of the roots. So this is if it was a cubic equation. This is quadratic. And quartic, you will have alpha, beta, gamma, delta. And you will have beta, gamma, delta plus alpha, gamma, delta, etc. So you will have the sum of triples on the top. So you'll have beta, gamma, delta plus beta would be multiplied by alpha, gamma, delta, then gamma by alpha, beta, delta, and lastly you will have alpha, beta, gamma on the top. And this is just the you can obtain those values by looking at the coefficients of x in the cubic equation. So you'll have others as we go along as well, and I recommend that some of them you know you will notice a pattern. It'll be easy to memorize. Right, so let's see how we can apply these results in the following question. So example 6, you've got alpha plus beta plus gamma squared. We've just been asked to expand this, so I don't really mind how you do that. You could just do a grid method. Let's do that. So you have alpha squared, alpha beta, alpha gamma, alpha beta, beta squared, beta gamma, alpha gamma, beta gamma, and then gamma squared. And you can see that here we've got alpha squared plus beta squared plus gamma squared, plus you're going to have 2 alpha betas, 2 alpha gamma, and 2 beta gamma. So 2 lots of alpha beta plus alpha gamma plus beta gamma. Okay, so over here we've got in part B a cubic equation with the roots alpha, beta, and gamma, and they are such that the sum of the pairs of roots is equal to 7, the sum of roots is equal to -3, and hence find alpha squared plus beta squared plus gamma squared. So when you get a question like this, you know you need to go back to this result over here, that when you expand alpha plus beta plus gamma squared, you get alpha plus beta squared plus gamma squared, and plus 2 lots of alpha beta plus gamma, alpha gamma plus beta gamma. If you rearrange it, you have an expression for alpha squared plus beta squared plus gamma, and it will squared, which is alpha plus beta plus gamma squared minus 2 lots of I'll just write it quickly, alpha beta. That's just a shorthand way of writing this. So over here, the sum of our roots, which is this one here, is -3. We need to square it, and 2 times alpha beta plus beta gamma plus gamma alpha, which is 7. So it's 9 minus 14, which is -5. Okay, there's some more results that you might find useful. They look very complicated. Okay. that you can have a question on. So the one that we've just done is the one that goes with a cubic. It's very similar to the one that goes with a quadratic. This you can just obtain by expanding alpha plus beta squared, or you could and then yes, so you get alpha squared plus 2 alpha beta plus beta squared, and then rearranging it. We've done cubic already, and this is you would obtain by getting alpha plus beta plus gamma plus delta squared, squaring it and rearranging it. These are all very, very similar, the ones on the left hand side. You can really put them together in a very shorthand version. So over here, if I have alpha squared plus beta squared plus, doesn't matter how many roots it is, what polynomial it is, you'll always get, as long as it's only squared, here you'll have the sum of roots of squared, and here you'll have minus 2 lots of the sum of pairs, product of pairs of the 2 roots multiplied together. So you could like this. So that's easy to remember. These here, the sum of cubes of a quadratic and cubic, you need to remember. For the quartic, you are not required to memorize it. I doubt we should get a question on that. So there are actually a lot of similarities here as well. So the sum of cubes is simply talking about now alpha cubed plus beta cubed. Okay, so for a quadratic, I'll just write this result straight away in shorthand version so you could see the similarities. You will have the sum of roots. There's only 2 roots, that's why it's alpha plus beta only cubed, minus 3 lots of, and here we're going to have the sum of roots times the product of pairs. Okay, so the sum of roots multiplied by the sum of the pairs here. There you go. Okay, now for the cubes of a cubic, and clearly here we'll have 3 of these. I'll actually write 3 of them like this. What is the result? What does it look like? Okay, so again you've got the sum of roots, the same as here, cubed, and minus you've got 3 lots of the sum of roots and the sum of pairs, okay, of the product. So it's 3 lots of the sum of roots and pairs. So only 2 here multiplied together, and here we've got, there's only 3 ways of writing these products, but it also has an extra bit at the end, so 3 lots of the product of all 3 roots. There you go. Okay, so let's see how we can use this result in example 7. So you've got a cubic equation. Let's just check the wording of the example. 3 roots of a cubic equation are alpha, beta, gamma, and given that alpha, beta, gamma is 4, then you've got the sum of pairs, so it's alpha, beta plus beta, gamma plus gamma, alpha, that's minus 5, and the sum of roots of alpha plus beta plus gamma is equal to 3. We've got to find the value of this expression. So clearly we want to multiply it out. I'm just going to multiply it out in a quicker way than just expanding 2 brackets and multiplying it by 3 brackets. So you're going to get alpha, beta, gamma, plus, then you will have 3 lots of beta, then you're going to have 3 lots of gamma, then you're going to have 3 lots of alpha, then you're going to get. Okay, so we've obtained that expansion. You could see that these are just our result over here that can be inputted into those alpha, beta, gamma. Is going to be 4. The sum of pairs here is minus 5. and here 9 lots of the sum of roots, which is 3 plus 27, and that's going to be 4 minus 15 plus 27, so 54, 58 minus 10, 48 minus 5 is 43. There you go. Okay, so now you can go and finish, have a go at exercise 4D.